Alright, pre-calculus concept 21C. We're now going to look at how to solve logarithmic equations by taking advantage of the opportunity to change it into exponential form. Kind of four important steps to remember in this process. Step one is to think about taking your expression, simplifying it or condensing it if possible, and isolating your logarithm. So we'll look at an example, but it's important to get the log all by itself. And then we're going to take our logarithm and change it into an exponential form. You've done this before. Remember our Roman numeral 9 trick. Every logarithm can be changed to an exponent. So that, which we've studied before, is going to be important. You're going to solve. And then a really important part of this process is to check your solution. Because logarithm has that special domain that we've talked about, you always have to check to make sure your answer works in the original equation, and we'll look at an example of that as well. Okay, let's start off with three examples. Number one, I have log base 4 of x plus 3 equals 2. The good news is I already have a single logarithm. It's also already isolated, so there's no need to do any work there. I can jump immediately to the changing form step. So I'm going to rewrite a logarithm as an exponential expression. Here's what I would get: 4 to the second power equals x plus 3. And you should feel really confident right away that this in exponential form is going to be pretty easy for us to solve. 16 equals x plus 3, and by subtracting 3 from both sides I get 13. Okay. Now, the check step is really important. I want to go back and think about, does in fact, let me do this in a yellow color, the log base 4 of log base 4 of 13 plus 3, which is 16, does that in fact equal 2? And for what we know about logarithms, that definitely works out. If there was an instance where my answer was plugged back in, and I got a negative quantity in there, and I tried to take the log of a negative number, that doesn't work, and that would be an extraneous solution, and I would answer no solution for the problem. We'll see one of those later on, but for now, we got an answer and it checked out. Okay. Example 2 is a natural log expression. Notice that you got a 3 there, and that makes it a little tricky to immediately convert it. And so this is an important step that you may forget, but isolate the log. So I want to get log 2x all by itself, and I can do that by dividing both sides. So my answer would be 4. Now that I have a single logarithm and it's isolated all by itself, I can convert this. This is going to be a base e problem. E to the 4th is going to equal 2 times x. My answer for this one is going to be e to the 4th divided by 2, right? That would be an exact answer. If you wanted to, you could get the decimal approximation on your calculator. If you want to check that out, it ends up being about 27.299. Okay, again, most of the time we'll want the exact answer, which would be this. Sometimes it'll ask for a decimal approximation, which would be that. Okay. If I think about a number like 27 and plugging it back in, there actually isn't any issues with domain because I'd have the natural log of 54, and a good opportunity to check your answer would be to take x, plug it back in, and see what happens. But this one does in fact check as well. All right, third example is a little tougher because I have more than one logarithm, and I can't use my conversion to exponential form right away. I actually have to work with this a little bit. So here's where all the properties we've studied have kind of come into play. So remember that if you have two logarithms that are being added, that I can take advantage of my product rule. And so another way of writing this logarithm would be to multiply x times x minus 7. And that gives me x squared minus 7x. And that is what equals 3. So all I did was condense the left side of the equation. Now I have a single logarithm. It's isolated. And you can now change this to exponential form. 2 to the 3rd equals x squared minus 7x. Okay, and that equals 8. Okay, now I've got work to do because now I have a simpler expression. There's no more logarithms, but I have a quadratic. And so you have to pull out your Algebra 2 skills and solve a quadratic. X squared minus 7x minus 8 equals 0. You could definitely use the quadratic formula here. Most of the time, you're going to get expressions, quadratic expressions that are factorable, so always try that first. This is going to end up being minus 8 and plus 1. So x minus 8 equals 0 is 1 of my solutions, and x plus 1 equals 0 is my other. My answers are x equals 8 and x equals negative 1. Okay, particularly in these problems where you have more than one answer, it's really important that you check. Right? So if I take the number 8 and I plug it back in, let's do this check in yellow. What is the log base 2 of 8? Well, good news is that's something you can work out. And the log base 2 of 1 is also something I can work out. Right, so this is 3. And remember that log base anything of 1 is 0. And so my answer is 3. And that's what I want it to be. So 8 checks out. If I do the check for negative 1, I get the log base 2 of negative 1. And you could stop right here because I've got a real problem. I cannot take the log of a negative number in any circumstance. Try it on your calculator, you'll get an error message. Doesn't exist. Right? So regardless of what the rest of the problem is, I have determined by checking that this negative 1 answer that emerged is extraneous, so you want to rule that out. So part of your work in this problem is to show that you actually checked that of the 2 answers I got, only one of them is actually correct. So here's my final answer, x equals 8. Alright, got 3 you tries, 2 kind of easy ones and 1 hard one. Let's have you try the first. Give me an answer for x in decimal form. Alright, this one you can immediately go to exponential form, and you should have gotten 8 equals x minus 4, and add 4 to both sides and you get x equals 12. Didn't need decimal form, sorry about that, but 12 is your straight answer. Plug it back in and check it does work. Let's try number 2. This one will be a decimal, so give your answer in decimal form. Okay, most important thing here is to isolate your logarithm first. People make that mistake all the time. So, divide both sides by 4 and you get a logarithm all by itself. And then exponential form would be e squared equals 3x. And your solution to this one is going to be e squared over 3. And from our answers, or doing that on your calculator, your best answer is approximately 2.46. Alright, final answer. Oh, sorry, third one. Give this one a try. Alright, a lot like example 3, we want to condense this first. That gives me x squared minus 3x. Then I want to change it to exponential form. I get 10 to the first equals x squared minus 3x. That leads to a quadratic, x squared minus 3x minus 10. Minus 10 equals 0. When I factor that, I get x minus 5 and x plus 2. My solutions to this one initially are 5 and negative 2. And hopefully you remembered to plug each of those in, make sure they work. Turns out 5 does in fact work, but negative 2, we get the same problem of can't take the log of a negative number, so that's an extraneous solution. 5 is our only answer.